So today we're looking at function compositions again. Now the most common function notation that we're going to be using is going to be prefix notation, which there's several different ways to write functions, and just to illustrate what we're doing, prefix notation means we are pre-writing what the function is before we write what we're plugging into it. So that's why we commonly say that we read functions right to left, is because I'm taking the rightmost thing, the x, plugging that into the g, plugging that into the f. Now that works for both different types of notations. This is going to be introducing a secondary type of function notation where I say, okay, f of g of x. And one of the things that you want to pay close attention to is that is not a times symbol as we've seen before. That is an open circle in between f of g. Now, we don't want to write this as f big circle g because that just looks like another variable. But f little open circle g means that I am taking this g and plugging it inside of f. Think open circle, there's an inside to be plugged in. What are we plugging in? We're plugging in the g. So both of them are going to be read as f is composed of g and g is composed of x, which means that x was plugged into g, which was then plugged into f. They're read the same way. They're even listed from left to right in the same way. But just to make sure we are familiar with this other type of notation in case we run across it, I've got a few different samples set up for you. So we're going to match the expression on the left with the expression on the right. Now if I look at this, I see a, which is composed of b, which is composed of x. If I want to write that in the alternate form, all I'm going to do is I'm going to say, okay, this means that a, which is composed of b, which is composed of x. So the innermost thing is going to be my x. Now if I look for that, a composed of b, composed of x, boom, this one's going to be an f. Likewise, if I work through this, I said, okay, a, which is composed of a, which is composed of b, which is composed of x. Let's go ahead and rewrite that in the alternate form. A of b of x. Ignore this really ugly a. We're just going to go ahead and make that work right there. Now I'm going to look for an a of b. Boom. I see that my answer right here is going to be D. And then likewise right here I have my b of a of x. B, which is composed of b, which is composed of a, which is composed of x. So if I write that in the alternate notation, looks like I have boba, which I think would sound delicious right now. I'm just looking for my b of a of x, which is going to be my a. Now the idea is that we want to get used to writing this. So if you wanted to go ahead and convert these into our original functions, I know that a is number 5, but I really want to get used to seeing, okay, if a of x is the first thing, I'm plugging that into b. And I'm plugging b into the larger b, which is going to look just like number 5. Likewise, if I see a of b of x, we just want to get used to plugging a function into another function in this notation. So I'm going to start with the innermost, b of x. And then as we said, we get slightly bigger with the parentheses every time we plug it into a larger function. By the time I get to the last one, a. So I'm seeing a of b of x, which is going to lend us to a of b of x, or a of b of b. It's going to be number 6. There we go. So we can go ahead and finish that. We're going to jump off to this. We're going to write out how the function composition is to be read out loud. So again, we just talked about this. We are plugging 2 into h and then plugging that answer into g. So 2 different ways we can read this. I can say g is composed of h, comma, and h is composed of 2. An alternate way that we could write this is we could read it from the inside out. So we could say plug 2 into h, then plug that answer into g. We plugged 2 into h, and then we plug that answer into g. 2 goes into h, that answer goes into g. 2 different ways we can read this. So why don't you go ahead and write out the two ways we would read that composition out loud. Okay. So this is saying R is composed of R again, and that R is composed of another R. Nope, not R, of another S. I misread the question there. I just saw lots of R's. That R is composed of, not another R, of S. And that S is composed of the variable x. So the first way that we can read that, R, which is made of R again, and that R is composed of S, and that S is composed of the variable x. The other way that we could read this is plug x into S, and then plug that answer into R, then plug that answer into R again. Again, 2 different ways that we could read this. If you want to read it in prefix notation, R, which is composed of R again, that R is composed of S, that S is composed of the variable x, or we could read it the way that we're probably going to evaluate it. Plug x into S, plug that answer into R, plug that answer again into R again. Awesome. And so now that we've gotten the idea of what the context reads, let's jump into this. We're doing some more compositions, but here we're doing it in the new format. So what we're going to look at is that we have a couple different functions, f, g, h, and j. And we're going to check out to see if we can match up our answers to our answers down here at the bottom. So what's going on? Let's go ahead and take a peek at some of these. So previously, before we get started, f of x is x squared minus 15, g of x is 2x plus 4, h of x is 1/2 of x minus 2, and j of x is going to be the square root all of x plus 15. Okay, let's go ahead and let's get started in number 11. So it looks like what we've got going on here is f of g of 10, which means I'm going to take 10, plug it into g, take that answer and plug it into f. So the first thing I'm going to do is I'm going to define my variables, or define my functions. F is x squared minus 15, and g, let's do g in blue. 2x plus 4. Okay. So the first thing I'm going to do is I'm going to evaluate out g of 10. We said I'm going to take that 10 and plug it into g. So for g of 10, we need to evaluate what g of x is. 2x plus 4, which means 2 of 10 plus 4. Perfect. So 2 of 10 plus 4, 2 times 10 plus 4 is 20 plus 4. That's going to give us a 24. So my g of 10 is 24. There's my first answer. And I'm plugging that answer into f. And so let's go ahead and say my f of g of 10 is going to be a 24. So what is f of x? Well, that is x squared minus 15. So I'm going to say, let's take that f and plug in a nice old 24. Okay, so 24 squared is 576, so let's write that out. 576 minus 15 is going to be, let's see, that's 566, 561. So this whole f of g of 10, so f of g of 10 is equivalent to 561. And let's double check to make sure that is one of our answers. Yep, that is going to be H. So that is answer H. Boom. Mark that down right there. Okay. So now that you've seen that, why don't you go ahead and try H of J of 10. Now, the first thing we're going to do is we're going to define our variable, or define our functions. We're going to call H, we're going to do that in green. H is 1/2 of x minus 2. And then let's define J in purple, which is the square root of x plus 15. Okay? So pause the video and pause when you're done and see how well you did. Okay? So what you probably notice is that we're going to read this right to left. I'm taking 10 and plugging that into J. So I'm going to define my J of, in this case, 10. And my J, which is defined as the root of x plus 15, is going to be the root of 10 plus 15. Okay. 10 plus 15 is 25. Root of 25 is going to be 5. So my J of 10 is going to give me a value of 5. And I'm going to take that answer and plug that answer into H. In this case, my H, I'm going to write this a slightly different way. No, H is not in red. We were not doing red. H is in green. So my H of x is 1/2 x minus 2. So I'm just going to write that out and say, hey, I'm plugging that into my H. So I'm actually plugging, put down that purple. I really want to use that. And we said J of 10 is 5. So I'm going to plug in that 5 and see what I get. Okay. Well, 1/2 of 5 is 5/2. 5/2 minus 2. I know to get that 2 to be able to subtract from 5/2 is going to turn that into 4/2. So that's 5/2 minus 4/2. So my final answer is 1/2. So my H of J of 10 is equivalent to 1/2. Let's double check to see if that is one of our answers. So we're going to zoom out. Yep, and it's the first one, A. Boom, there we go. How well did you do? So we got 2 more that we're going to try. Let's go ahead and give 15 a shot. We've got J of F of 10. Give this one a shot and see if your answer, what goes on. Okay. You might need to see the functions, so I'm going to go ahead and put those down. J of x is the root of x plus 15. And then F, we did F in red, is x squared minus 15. Awesome. So now give that a shot. Okay. So as we walk through this, I'm going to take the value of 10 and plug that into f. So I'm going to go ahead and jump immediately into the f and say, hey, I'm plugging 10 into that. X is x squared minus 15, which means I'm plugging 10, squaring it, and taking away 15. So 10 squared is 100. 100 minus 15 is going to be 85. So when I say f of 10 is 85, that's my first answer. I'm going to plug that answer into my next function, which is j. And so I'm plugging j of x. I'm plugging in that 85. So I'm just going to go ahead and immediately plug in that 85. Into j of x, we said that was x plus 15 all rooted. Okay. So what we see happen here is 85 plus 15 is 100. The square root of 100 is 10. Boom. So we know that j of f of 10 is 10. Let's double check, make sure that is one of our answers. Boom, it is. It's either D or E. We've got two choices. So I'm just going to go with the first one, which is D. And so one of the points that we want to make here is that j of f of 10 is actually an inverse function relationship. So what we saw is we plugged in the number 10 and we got 10 back as a result. All an inverse function means is that it undoes everything the other function does. If we looked at what we did, well, we squared it and took away 15, and when we went to the next function, we added back the 15 and then square rooted it. So if a function is an inverse of another function, it just means that it undoes everything within that function and gives you back your original input. Feels bad because you're like, hey, I went through all this trouble to make this thing. I give this thing to you, and you just undo everything. Kind of like siblings. My sibling's going to kill me for that one, but we're going to pop off onto number 17. So 17 is the last one, and this is a triple composition. So pause the video, unpause it when you're done, and see how well you did of these three functions. G, we did G in blue. And H, we did H in green. Perfect. So give that a shot. Okay. So we're going to read this from right to left. I'm plugging 10 into H. I'm going to take my green. I'm going to say H of 10. 1/2 x minus 2. Okay. Then I'm going to accelerate this a little bit in the way that we write it. So I'm not going to write out every single little piece. So H of 10 is 1/2 of 10 minus 2. Let's see. Half of 10 is 5, minus 2 is 3. So H of 10 is 3. Well, I'm going to take that, and I'm going to plug that into G. So G of, let's plug that in, 3. Equals 2x plus 4. Okay. So G of 3 is 2. 3 plus 4. 2 times 3 is 6, plus 4 is 10. So G of 3 is 10. So it looks like H and G are also inverses because we did the thing with H, got a number, and then G just turned around and gave us right back our input, which in turn we're going to plug into F. In this case, this is going to be F of x squared minus 15, 10. And when I plug in that 10, I get 100 minus 15 is 85. So my full answer, if I want to write this out, f of g of h of 10 is 85, and let's check to see if that is one of our answers. Yep, it is F. Boom. Boom. And there we go. Function composition.